and welcome to Chapter 16, Solutions. In this chapter, we're going to be talking about the properties of solutions. We'll also be talking about concentrations of solutions, how to make solutions of a given concentration, how to dilute solutions to a given concentration, and the various ways that we can report concentration. We'll also be talking about colligative properties, which are those properties that only depend on the number of particles dissolved in the solution, and then we'll wrap up this chapter in 16.4 by doing calculations of those colligative properties. So let's go ahead and get started. 16.1, Properties of Solutions. The first thing we want to talk about is how solutes dissolve, or how fast we can get them to dissolve. Now, there are three factors that determine how fast something will dissolve. You have stirring, temperature, and surface area. Alright, so let's talk about these. In terms of stirring, let's go ahead and draw a picture here. If I have a substance, let's just make it a cube, whatever it is, inside of my solution. As I put the spoon down in there and stir this thing around and around, what happens is that any particle that comes off from this particular cube is going to get whisked away to a different area, and it's going to bring fresh solvent to try to dissolve more particles. So the more you can whisk these things away and bring in more fresh particle or fresh solvent, the better. If you don't do that, some of these particles that are actually coming off from the cube can actually reattach themselves. So if you can move them away from the original solute, you can get these things to dissolve quicker. Alright, and that makes sense, and obviously you guys have stirred plenty of things in making food or whatever, but it has to do with making sure that they don't reattach themselves to the original substance. Now, temperature works the same way, so I guess let's just say more stirring or more agitation means faster dissolving. Now, in terms of temperature, temperature is related to the speed of the particles. So when you increase the temperature, particles are colliding with a solute harder. So just say particles collide with solute more frequently and more violently. And so what happens is if you have a sample, let's go ahead and just draw it right here. There's my beaker of water or whatever solvent we have, and here's the cube that we put in there. What happens is the solvent particles will strike the solute cube or whatever that's in there, and it's going to jar these things loose. It'll jar the particles off. Furthermore, it will quickly take the particles away themselves. So even if you're not stirring, the simple rapid motion of the particles will move the solute away from itself and allow it to dissolve quicker. Obviously, the colder the temperature is, the opposite effect happens. And then finally, in terms of surface area, the greater the surface area you have, and I'll just say SA for surface area, the greater the surface area, the faster it dissolves, and here's why. If we have two samples, here's the first cube, it's only the outer edge of this cube that the water molecules are colliding with. However, if you grind that up into a fine powder, now the water molecules can get to a lot more of the particles. So if you grind this down to a fine powder, it's going to dissolve much, much quicker as the water molecules engage many more of the solute particles at one time. So this is what you want to have if you want to go faster in terms of dissolving something. Alright, so those are the three factors that affect how fast something is going to dissolve. Now, in terms of solubility, solubility is the amount of solute that can dissolve in a given amount of solvent at a given temperature. Now, usually they're going to report this as something such as grams of solute per 100 grams of water. Excuse me, or if you're dealing with dissolving a gas, the grams of gas per liter of solvent, something to that effect. Now, once you've reached what's called saturation, or a saturated solution contains the maximum amount of solute that can be dissolved. And again, at that temperature. If you're not at the maximum, the solution is said to be unsaturated. So we'll just say it contains less than the maximum amount. There's the difference. So you have saturated and you have unsaturated solutions. Now, as you try to dissolve various solutes in your solvent, you have what are called miscible liquids and immiscible liquids. Miscible liquids can completely dissolve. Ethanol in water, you can dissolve as much ethanol as you want in the water, or vice versa. But not all substances are like that. If a substance cannot dissolve in one another, it's said to be immiscible. Oops, let's try that again. Cannot dissolve in one another. Oil and vinegar is a common example of immiscible liquids. They do not dissolve at all. Versus the ethanol in water for miscible liquids. Okay? Now there's a whole continuum in here where you have partially miscible, where you can dissolve some, but only to a certain point. For example, water and diethyl ether. You can dissolve some diethyl ether in the water, but not much. And so once you reach that saturation point, they're not going to mix anymore, and you'll actually have a layer of diethyl ether in water in two separate layers based on their densities. Okay? So those are just some terminology that you should learn and should know about solutions in general. In the next podcast, we're going to take a look at the factors that affect solubility. We'll see you next time.